Hey everyone, so here I'm doing exercise 6.3, 6 question of square and square root. And the question is, for each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square. Also, find the square root of the square number so obtained. We have a 6 question to solve here. So these 6 questions are actually not a perfect square numbers. We have to make it perfect square by dividing with the smallest number. So we're going to start with the first one, which is 252. So we're going to use a prime factorization method whenever they're asking to multiply or divide the smallest number. So I'm going to take the number 252. Remember, these numbers are not perfect square. So we'll take a 252. I'll do a prime factorization. So you're supposed to take only prime numbers when you're factorizing it. I'm going to start with 2 because the given number is an even number. I'll get 126. Again, I'll take a 2. So this will be 2 6 are 12 and then 2 3s are 6. We got 63. This is divisible by 3. We cannot take 2. So I'll take a 3 here. So we'll get 3 2s are 6 and then 3 1s are 3. That is 21 we'll get. So 21. Now this 21 is again divisible by 3. So I'll take 3 again. So 3 7s is 21. So 3 and then 7. And then 7 is a prime number. So we'll get 7 1s are 7. Now whatever factors I got here, I'm gonna rewrite this. So 252 can be written as, write down all the factors what you got. So 252 is equal to 2 into 2 and 3 into 3 and then followed by 7. So 2 into 2 into 3 into 3 into 7. So you might have learned that for the perfect square number, the prime factorization when you do, this is supposed to be in a pair. So here 2 has a pair, 3 has a pair, but 7 doesn't has a pair. And that is why 252 is not a perfect square. So the asking is smallest number to be divided. So if I remove the 7 from here, you can see that I'll get a pair of 2 and 3. And that makes the number perfect square. So I'm going to divide both the side by 7 because this 7 does not have any pair number. It is just single there. We can cancel 7 on both the side of the right hand side and just divide 252 with 7. We'll get 36. So 36 is equal to, just write down whatever is left, 2 into 2 into 3 into 3. And we know that 36 is a perfect square. You can find a square root of it. So square root of 36 will be nothing but 6. Or you can just take a 1 factor from each pair. So from 2 factor I'll take 2 and from 3 I'll take one single 3. 2 3s are 6. So this is the first question we have got. Let's move on to the second one, which is nothing but 2925. So for the first question, the smallest number to be divided will be 7 because 7 doesn't has a pair. The same method we're going to apply for the rest of the numbers. So 2925. So next number is 2925, 2925, and this number is not an even number. So I'm going to start applying with the 3. I'm going to check with the 3 and then followed by 5. So 2925. Now let me go with 3 here. So when I do with 3, 29 is not divisible, so I'll take a 27. So 3 9s are 27, 2 will be the remainder, that makes the number 22, right? The remainder is 2. So 22 is 7s are 21, so 1 is left, 15. So 3 5s are 15. 975 again divisible by 3, so 3 3s are 9, 3 2s are 6, 1 is left, so 15, right? So 3 5s are 15. Again, I'm going to try with 3. 3 1s are, no, it is not divisible by 3. We had to go with 5 here. So 5 6 are 30. 2 is left. So it's 25. 5 5s are 25. So I'll get 65 here. Now 65 is again divisible by 5. 5 13s are 65. So 5 1s are 5. 1 will be left. That makes the number 15. And 5 3s are 15. Now 13 is a prime number. It doesn't go in any table. So I have to take 13 1s are 13. Now again same thing. Let me write down what I got here. So 2925 can be written as, write down all the factors what we got here. So you got 3 into 3 and then 5 into 5 multiplied by 50 or into 13. So here you can see we got a pair of 3, we got a pair of 5, but we don't have any pair for 3. So if I want to divide with the smallest number, that will be 13, because this 13 is not forming any pair. So I want to divide both the side by 13. See, you have to make the change on both the side. So 2925 is not perfect square. I'm going to divide with 13 on both the side. On the right hand side, they'll get cancelled. On left hand side, I have to divide the number with 13. So 13 ones are, and here again 13 ones are 13, or 13 twos are 26. So I'm going to take 2, 26. 3 is left, so again 2s are 26, again we'll get 65, so 5s are, so 225. So 225 can be written as 3 into 3 into 5 into 5. So you can see that 225 is an exact pair here, 3 into 3, 5 into 5. So square root of 225 is nothing but from each pair take one factor. So that is 3 and 5. So 3 5s are 15. It's 3 into 5. So this is quite simple method. Only thing is you should know how to do a prime factorization. That's it. So that is the second question we got. Let's move on to the third one. Now third question is 396. This is an even number. So I'm going to start doing a prime factorization with a 2 as a factor. So let me write down the number here, 396. So I'm going to begin with the 2. So 2 ones are 2. So 1 is left. That makes a number 19 there. 1 is a remainder. So 2 9s are 18. 1 is again left. 2 8s are 16. 198 is again an even number. So I'll go again, and again I'll take a 2. So 2 9s are 18. 1 is left. 9s are again 18. Now 99 is divisible by 3, not by 2. So I'll take a 3. 3 3s are 9. Again 3 3s are 9. We got 33. This 33 is again divisible by 3. We'll get 3 11s are, and then 11 is a prime number, 11 ones are 11. Again do the same thing. Write the 396 as whatever factors you got, just rewrite it. So 396 is equal to 2 into 2 into 3 into 3 and again into 11. I hope by looking at the question you might have got that 11 doesn't has any pair. 2 and 3 got a pair, but 11 is single here. So the smallest number to be divided here will be 11. If I remove the 11 from here, I get a perfect pair here. So divide 11 on both the side, and on right hand side 11 will get cancelled. On left hand side, just cancel the 11 and 396. We'll get 36 again. 11 ones are and 11 36 are. So 36 is equal to 2 into 2 into 3 into 3. This is somewhat we got in the first question also. So 2 into 2 into 3 into 3. Now take a square root of 36. So just take a 1 factor from each pair. So it's a 2 into 3, which is nothing but 6. Okay. So with this, we're done with the third question also. Let's move on to the fourth one. So next number is 2645, and this number is not divisible by 3. So we have to take a 5. We're going to start with the 5 because it is not divisible by 2 nor with a 3. So 2645, and then I'll start with 5 as a prime number. So I'll get here 5 5s are 25. 1 is left, that makes a 14. 5 2s are 10. 4 will be left, so that makes a 45. 5 9s are 45. Now remember, this 529 is a it is a square of 23. You can just check with any prime number. It is not divisible by any number except 23. So this is a unique here. 529 is a square of 23, which is a prime number. 23 is a prime number. So we got here 2645 is equal to 5 into 23 into 23. Okay, so from here itself you can say that 5 is not paired and 23 has a pair here. So I have to remove 5. So divide both the side with the 5. So on the right hand side 5 will get cancelled, and on the left hand side you have to divide the given number with 5. So 5 ones are, and then 5 5s are 25, and then I'll get 1 left. 5 2s are 10 and 4. I'll get 529 here on the left hand side. That's it. So 529 is equal to 23 into 23. Like I told before, it is square of 23. So square root of 529 will be 23. You will get a pair of only one pair here, that is 23. So 529 is equal to, from each pair you should take one factor. We have only one pair here, that is 23. That's it. Now let's go on to the next one, which is the fifth question, and we have a 2800 for the fifth one. Now 2800 is again an even number. We're going to do a prime factorization. It will be a bit lengthy one. It's a huge number. So I'm going to begin with 2. So let me write down the number here. It's a 2, 8, 0 and 0. So I'm going to start with 2. 2 ones are 2, 2 fours are 8 and then zeros. And then again 14 we have, so 2 sevens are 14. So 2700. We'll get 700. Again 700 is divisible by 2. A number which is ending with 2 with the 0 is divisible by 2. So I'm going to keep on doing with 2 until I get a different number. So 2 3 are 6, 1 is left, 2 5s are 10s and 0 again. And 350 is divisible by 2 again. So 2 1s are 2, 1 is left, 2 7s are 14, again 1 is left, 2 5s are 10. Now 175 is not divisible by 2. So I have to take have to take any other number. So I'm going to take a 5 here because it is not divisible by 3. So 175. I'll start with 5. 5 3s are 15 and 2 is left, 5 is 25, and then 5 7s are 35 and 7 1s are 7. So let me write down what I got here. So 2800 is equal to, write down all the factors what you got. This will be a bit lengthy. So 2 into 2 into, again 2 into 2 into 5 into 5 into 7. Now start pairing up a numbers. So I have a pair of 2, I have one more pair of 2, I have a pair of 5, and 7 doesn't has any pair. So the smallest number to be divided here will be 7. So divide 7 on both the sides. So cancel the number. 7 ones are and 7 fours are 28 and followed by 2 zeros. So 400 can be written as, all the factors what you got left out on the right hand side, just write down 2 into 2 into 2 into 2 into 5 into 5. And just pair up the numbers and take the square root of it. So square root of 400 will be nothing but, from each pair you take one factor. So pair up the number. I have a pair of 2, I have a pair of 2, again pair of 5. So from each pair take one factor. So 2 into, again one more 2 into 5. So 2 2s are 4, 4 5s are 20. So square root of 400 is nothing but 20. And smallest number to be divided will be 7. Now the last question is nothing but 1620, that is 1620. So same thing. I hope by this time you would have cleared how to solve this kind of problem. So I'll do a prime factorization of 1620. It's an even number. We're going to start with 2 again. So 1, 6, 2 and then 0. So let me take a 2 here. 2 8s are 16 and 2 1s are 2 and then 0. Again we'll take 2. 2 4s are 8. 1 is not divisible, so 0, and then 5s are 10. Now this is not divisible by 2, so we'll take a 3. 3 1s are 3, 1 is left. Again 3 3s are 9. 1 is left, 15, so 3 5s are 15. Now 135 is divisible by 3 again, so 3 4s are 12, 1 is left, 3 5s are 15. Again divisible by 3, so 45 I'll write here, and 3 15s is 45, so 3 3 1s are 3, and then 1 is left, 3 5s are 15. We'll get here 15. Now 15 is again divisible by 3, so 3 5s are 15. So 5 is again left, so 5 1s are 5. Now let's rewrite what we got here. So 1620 can be written as, write down all the factors. It's a 2 into 2 and then 3 into 3. We have many 3s here. We have 4 3s here. So 1620 is equal to 2 into 2 and 3 into 3 and again 3 into 3 and again into 5 will get. Now once you have written all this, you have to start pairing up the number. So you can see that 5 is left a single, it doesn't has any pair. So you have to divide both the side by 5. So let me pair up the numbers. So 2 and 3 has a 2 pairs here and then 5 is left out. So divide both the side with the 5. So when you divide on the right hand side, the 5 will get cancelled. On the left hand side, you have to multiply. You have to divide with 5. So when you divide, you will get 5 3s are 15. 1 is left. 5 2s are you will get here 2s are 10. 2 is left. So you get 324. Yeah, 324 is actually square root of 18. So 324 is equal to, write down all the factors you got on the right hand side. So 2 into 2 and then 3 into 3, again 3 into 3 and again 3 into 3, again into 3 into 3. Now square root of 324 is equal to, just take a factor from each pair, that is 2 into 3 into 3. Multiply them. So 2 3s are 6 and then 6 3s are 18. So that's it. The smallest number to be multiplied is not, the smallest number to be divided here is nothing but 5, and a square root of 324 is equal to 18. So that's it. We have done all the 6 problems. I hope it's clear. Thank you so much for watching.